Okay, this is our video about wheel and axle mechanical advantage. And the first thing I'd like you to notice is, what does it look like they have drawn here? If it looks like a lever, that's because that's what this is really. This is really a wheel and axle is really like a lever that we've attached to the axle, where the fulcrum is at the axle of the wheel. So if you think about it like that, this is really very, very, very similar to what we already saw in the levers. So let's look at how the formulas work with this. So IMA equals DE over DR. Same exact formula we had with the lever. So if this is my effort here, and this is my resistance, what distance does the effort travel? Well, it would travel as the outside circumference of this circle. So this would actually be pi 2 pi r. The distance, which is the circumference, which is the distance around this circle here. Or I could think about it as pi d. Also the equation for the circumference. And this time we would be talking about to the effort here. And then this part where I'm pushing here at the axle, it would be the same thing, but it'd be 2 pi radius to the resistance, or pi diameter to the resistance. Well, in math, if I have the same thing on top and bottom, 2 over 2 is just 1. So these cancel and these cancel. And then in this one, these cancel. So when I'm talking about the MA for a wheel and axle, I can think about it as the distance effort over distance resistance. Or it's the same ratio as just the radius to the effort over the radius to the resistance. Or the diameter to the effort over the diameter to the resistance. Mathematically, it's the same exact thing. I don't have to calculate the circumference every single time. I can go ahead and just use the radius or the diameter. Now it asks two different questions down here about the IMA. So in one case, this could be like a car where I have a motor turning the axle, which in turn turns the car, where this is the effort and this is the load. In that case, IMA equals distance to the effort over distance to the load. The effort would be here at 6 inches, and the resistance would be out here at 20 inches. Units cancel, and I get 3/10. You can give it as a fraction. We do reduce it from 6 over 20 to 3 over 10, or we could give it as a decimal point 3. Very often it's given as a fraction and just left there. Now what if I switch it? What if the wheel drives the axle? For instance, this is something that I'm pushing like a wheelbarrow, and I'm pushing it, and so my effort's actually on the outside here. Or the steering wheel of your car. On the steering wheel of the car, you're holding on the outside of this, and it's turning the axle here. So now this is the effort, and this is the resistance. Write the formula. Now this is the effort here at 20 inches, and the resistance is here in the middle at 6 inches. Units cancel, and I get 10 over 3, or if I put it into a number, 3.3. So it changes the mechanical advantage depending on which one is where my effort is. Now what about the AMA if the wheel is driving the axle? So here the wheel, this is my effort, and this is my resistance. So the AMA is FR over FE, exactly the same thing we saw with the levers. FR is 70 and resistance is 200. And in this case, we're getting a slightly different number than here because there is friction on this one, which we won't see very often. But we get 7 over 20 or you could put that in your calculator to get a decimal. Okay, we're going to do a couple more examples here. First example, do they have a picture drawn? Then we need to draw a picture. So I'm going to draw a picture. It's just a wheel. It's not fancy, just a wheel. And it says the wheel of a small dirt bike has a diameter of 2.5. Do you remember the symbol for diameter? It's a symbol like that for diameter. We learned that in IED. And I'm going to put my little symbol there for feet, 2.5 feet. And the axle has a diameter of 2 inches. Do you already notice a problem? Feet and inches. We need to convert. I'm just going to convert this one over to inches. 2.5 feet in inches is 2.5 times 12. So 2.5 times 12 inches. And we find that this is 30 inches. And it hasn't told me which is effort yet. But if we're talking about a dirt bike, how does a dirt bike work? Well, you turn the pedals, which turns the axle. So this is where my effort is. And this is where my resistance is. Oh, these are D's. Sorry, D-E, D-R. Okay, so what is the mechanical advantage of the wheel and axle? So if I only know distances so far, this has to be IMA. I'm going to put it down here. Equals DE over DR. DE is 2 over DR is 30, making it 1 to 15, or we could do that on our calculator, and we get 0.067. B, and notice this was inches over inches, those cancel, no units on IMA. Next it says, what's the circumference of the wheel? Well, we talked about it earlier, circumference equals 2 pi r or pi d. I know the diameter is 30 inches, so pi times 30 inches. Pi is 3.14. Do this on your calculator. And you get 94.2 inches. If you don't put inches on that, it's going to be wrong because you don't have units. Part C. Part C says, if the axle makes one rotation means it goes around one time, how far is the bike traveled? Well, just think about it. If I'm talking about the axle going once, the wheel goes once. So this is by the time this thing rolls around one whole time, how far is it gone? Well, it's literally gone the same thing as the circumference. So this distance in one rotation is the same as the circumference we just found. So it's 94.2 inches. What if it turns 200 revolutions per minute, or rotations per minute? How fast is the bike traveling in miles per hour? We're going to have to do that conversion. And so we'll have to do a couple. In order to do these conversions, you learned how to do this in IED. We start with 200 revolutions per minute. And what conversions do I need here? Well, the first one is 1 revolution is how many inches? Well, it's 94.2 inches. So revolutions cancels with revolutions. Now I have inches per minute. Well, I don't want inches. I need to go to feet. So 12 inches is 1 foot. And then, how many feet in a mile? Well, 5280 feet in 1 mile. You can look that up on your conversions in your formula chart. And now I've got miles. I want miles per hour. I've got miles per minute, so now I need to change the minutes. So 60 minutes in 1 hour. I line up the minutes so that there's a minutes on bottom and a minutes on top to cancel. And now I've got all my little units here. So now I just need to plug this in my calculator. I really suggest you go straight across the top and straight across the bottom. So 200 times 94.2 times 60, that's the top. And I get this number. Then I go straight across the bottom. I've got 12 times 5280. Then I go back and divide them. And I get 17.84 miles per hour. Okay, and our last wheel and axle example, I've got a picture, screwdriver, and it gives me some information here. And it says, what's the MA of the screwdriver? Well, this is the diameter of the handle. So where's my effort? At this end or this end? Well, this is my distance effort, because this is where you actually turn the screwdriver, and this is where my load is over here. Do I even need this length? No. The length doesn't even come into it. So we're going to use IMA equals DE over DR. DE is 2.4 centimeters. DR is 0.36 centimeters. And if I divide those, we get 6.67. Again, 6.67 means that it's more than 6 times easier to turn it here than if you just turn the screw with your fingers. Then it says if 7 pounds of pressure of force is applied at the handle, that's where the E effort is, how much force do you get at this end on the screw? Well, so I'm going to use AMA equals FR over FE. I don't know my FR, but I do know my AMA is the same as my IMA. I don't know FR. And I do know my effort, they said, was 7 pounds. Multiply these together, and we get the FR is 46 pounds of pressure. With just 7 pounds here, I'm getting 46 pounds to turn the screw. This is why we use screwdrivers. And then it says, how does the MA make screwdrivers useful? Well, if you've ever tried to turn a screw with your fingers, unless it's really loose, it's really hard to turn it. By making a big handle on the screw, we've made it so that I can just put 7 pounds of force in, and I get almost 50 pounds of force out to turn the screw. That's how the MA helps us out. Okay, now you need to do the problems on wheel and axle.